In this recording, I hope to give you an example, a case study, so to speak, for the Unit 4B portfolio on uses of data. So what we're going to do is we're going to work through an example of a complete study, in this particular case, for a t-shirt company. So what I'm going to do here is I'm going to set out a hypothetical table of values or of sales of t-shirts for the t-shirt company. Okay. We'll call the t-shirt company Tyrel's Tees. How's that sound? Tyrel's Tees. Okay, and we're going to have some months here. Let's go month 1, 2, 3, and actually we're going to say month 0. We're going to call the first month 0, and then 1, and then 2, and then 3. Maybe 0 is January, 1 is February, 2 is March, 3 is April, month 4, May, and we're going to stop right there. I'm going to keep it fairly simple by keeping the amount of data we're working with small. Okay, and then we're going to have sales. And we're just going to list the number of tees that were sold in that given month. So in January, we sold 42 t-shirts. 51 in February, 52, 63, and 70. Okay, so those are my sales for those given months. So use your imagination. Step 1, develop and describe a real-world problem. Identify the issues. So we've got a t-shirt company, and we're producing t-shirts. And I'm concerned about the growth model for my company, that the number of sales are going up, and I want to know if my staffing situation is sufficient. Right now it's just me. I'm doing the orders all by myself. Okay, I can handle producing, say, 200 t-shirts every month. I can handle that myself. But once I get over that 200 mark, you know, I really need to consider hiring staff to help. So my question really has to do with when can I safely predict, or can I even predict when that might occur, so that I can make plans for hiring, because it takes time to hire new staff, to find and hire new staff. Okay, so that's kind of the question I'm going to try to answer. So step 2, simplify the problem statement. So I'm going to answer the question: when do I expect the amount of sales will peak over 200? Okay. And step 3, determine the data needed to answer the question. In this case, the data I'm working with is sales over the first 5 months, actually, first 5 months of my operation. That's not a lot. I'm keeping it simple for the sake of this presentation. You probably want to deal with more data, a longer list than this, maybe a year's worth of data to predict more safely. Okay. And then step 5 is analyze the data. If relevant, create a data table, scatter plot to represent the data you gathered. Insert them here. Okay. Be sure to describe your methods, in other words, explain the strategy. And we're going to do a linear correlation. Okay. There's other types of correlations besides linear. We might explore that a little bit. Okay. So what I'm going to do here is I have my data table. I'm going to make a scatter plot. Okay, my cats are talkative right now. Okay, so we have month 0, month 1, month 2, 3, 4, I'm going to say 5, 6, 7, 8, 9, 10, 11, 12. And I need to get up my vertical scale up to 200. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 5. So if I go, yeah, so if I go 20, 40, 60, 80, and then 0 down here, 100. Yeah, that'll work. 120. So we're basically going 10 per tick mark. 140, 160, 180, 200. Okay. So my vertical scale is sales. My horizontal scale is month. Grab my straight edge here. When you do your graph, you can do your graph in Desmos. That would work. You can do your graph on graph paper. Just photograph it and attach it. Or insert it in a Word document. There's lots of ways to do that. Okay. So here we go. All right. And now let's plot our data. Okay. So on month 0, we had 42 in sales. This is 50, so 42 is right about here. And month 1, February, we had 51. So a little bit over 50. Okay, month 2 in March, we had 52. Just a little bit over 50, but a little higher than the previous. Barely recognizable in this scale. April, the 3rd month, we had 63. 63. Here's 70, so 63 is like right here. Okay, in May we had 70, so the 4th month we had 70 right here. Okay, and it looks like I probably will have to extend this a little bit here. Okay, all right, so now we're going to do something called a line of best fit. Okay, we want to fit a data line to this data, a line of best fit to this data, like I showed you in the previous one, the previous portfolio. We try to match the slope, the steepness of the line. Okay. All right. So something like this. All right. And then we're going to draw our line. And as you can see, it doesn't reach 200 anywhere in my graph. I could extend my graph to figure this out, but I'm going to avoid doing that here for now, okay? Because I'm going to come back to that answering the question. We're going to use a formula to actually answer the question. I could extend this on the graph and extend my scales and find out where the yellow line reaches a height of 200, and that would work, okay? But I'm going to use a little different method here. Okay, so now we're going to write the line of best fit. It seems to cross. I've made it so that it crosses right here at about 42. Okay, I'm going to look for another grid point here. Here's a grid point right here. Grid point is where a vertical line and a horizontal line and my diagonal line meet at a common location. This seems to be the point 8 and 90. Okay. So now I need to figure out my slope, which is rise over run. Okay, so we think of it this way here. You can use the slope formula, change in y over change in x, y2 minus y1 over x2 minus x1. Okay, or you can just think of it the height of this triangle. Remember, each one is 10, so 10, 20, 30, 40, 50. 50 less 2 is 48. So from 90 down to 42 is 48. Okay, and the width is from 0 to 8, so the width is 8. So my slope is 48 and divided by 8. Okay. Okay, now 6 times 8 is 48, so that's a slope of 6. So here's what this tells me, right? Interpret this. This tells me we increase 6 t-shirts each month. So every month on average, we add another 6 t-shirts. So we can actually thinking about that and use that to make a prediction. But now let's write the equation. Y equals mx plus b. Okay. So y equals the slope, that's 6, x plus the y-intercept, 42. Okay. And we now have a formula for a regression line. We call it a regression line, or a line of best fit. Technically, it's not a regression line. Okay, now I want to answer the question that I posed at the beginning of the problem, and that is, when can I expect to need to hire staff, additional staff? Well, that's going to happen when my sales equal 200 or get above 200. Okay, so basically I'm going to solve this equation. 6x plus 42 equals 200. Okay, so let's go ahead and do that. So let's see. So I'm going to subtract 42 from both sides. So that's 158. Then I'm going to divide 6. 6 times 2 is 12 with a remainder of 3. 6 times 6 is 36 with a remainder of 2. So 26 1/3. So obviously I can't sell 26 1/3 t-shirts. So I will need, or actually the X doesn't represent t-shirts. X represents the months. All right, so we can have 26 1/3 months. So here's the answer to the question. In 2 years, which is 24 months. In 2 years, 2 months, so 24 plus 2 is 26. And 1/3 of a month is about 10 days. I will need help. Okay, so I've got some time, and a little over 2 years. Now, do you think this is going to hold fast or hold true? The answer is no. So we get to step 7, interpret and revise the model. Okay, and that is compare the information in step 6 with the information in step 4. Evaluate the mathematical results from the model. See how closely they relate to the original problem statement. Check that the results make sense. Does the data seem to fit? If it doesn't, you need to start over again. So analyze your results and see if we need to modify the model. Now, let's say for example, that the following happened. Let's say that we recorded month 5 in June, okay, and month 6, July, and in those months we actually went down 68 and 60. Okay, in which case I would be adding additional points, 68 and 60. Now my regression line no longer makes sense, and in fact the model that I've got needs modification. Okay, so starting at 42, my incline actually is more like this. Okay, and I would need to modify my model to fit the new data. Okay, and this happens in business all the time. We make predictions based on the data we have, and then as we collect more data, we see new trends, and we modify or change our problem as a result. And in this case, I would probably need a new employee probably in about 3 years, right? So this is kind of an explanation. So remember, this is a writing assignment. So make sure you write out your answers to each of the 7 steps, okay? Write out your answers to each of the 7 steps. I haven't demonstrated that here, but you need to write your answers to each of the 7 steps, making sure that you've walked through all of the steps. Hopefully that answers any questions.